Alright, this video is going to cover the periodic tables. It's going to cover how we made the periodic table, what scientists were involved in that, and what are the groups of the periodic table, what are their properties, how many valence electrons they have, and how reactive they are. The first person we talked about in terms of the periodic table was Mendeleev, and Mendeleev arranged the elements in order of increasing atomic mass. And when he did this, he had elements forming a repeating pattern. So that's why it's called the periodic table, because he saw a periodic pattern and there was a certain number of valence electrons in each, which he didn't realize. He only knew that due to reactivity, and he started to notice some similarities between all of the properties. There's three different classifications for elements. There are metals, nonmetals, and metalloids. And they have specific properties. Another thing we look at on the periodic table is valence electrons, and valence electrons are just the number of electrons in the outside energy level, so the last energy level. When we're looking at the metals, they're always generally on the left side of the periodic table, and for the most part they have few valence electrons, like 1, 2, or 3. Metals tend to be shiny, like reflecting light, ductile, meaning that they can be pulled into strings, malleable, meaning they can bend, and they are good conductors of electricity and energy. Nonmetals act the opposite of metals. So nonmetals are found on the right side of the table, and atoms of most nonmetals have almost a complete set, which would be 8 valence electrons. So they tend to have a high number, like 5, 6, 7, or 8. Nonmetals are not shiny, meaning they're dull. They're not ductile, they cannot be pulled into strings. They are not bendable, which means that they are brittle. And they are not bad conductors. They're not good conductors of electricity or heat. Metalloids are the blue squares kind of in between the metals and the nonmetals. So metalloids have about a half of a complete set of electrons. Metalloids have some properties of metals and nonmetals. So for instance, a lot of the time if you look at those pictures, they look like they're shiny. You might think they might be metals, but in reality, if you tried to bend them, they would break. It's kind of like a false metal. You think they're a metal, but they're not. And they are also not great conductors of electricity. They're kind of halfway conductors, which makes them semiconductors. So they're not excellent. All right, the next part we're going to do is label a square of the periodic table. So the first thing we're going to do is look at the top. Carbon is the name of the element. The number 6 would be the atomic number. C is the symbol. And 12.011 is the atomic mass, which is the weighted average of all the naturally occurring isotopes. When you're looking across the periodic table, those are called periods. Up and down, those are called groups. So when we're talking about the groups, you always count from left to right. The part that's highlighted in green, it's group 1. They are called the alkali metals, because every single one in that section is a metal. We don't include hydrogen in this group, because that's a nonmetal. They have 1 valence electron. They are very reactive, and they tend to be soft, silver, shiny, and have a low density. So just to prove that it has 1 valence electron, we're going to go back in, we're going to draw in, we could draw lithium, or we could draw sodium. Let's draw sodium. Sodium has 11 protons and 11 neutrons. And we'll draw on the electrons here. We're going to put 2 in the first energy level, 8 in the next, and then 1 on the outside, so it shows that it has 1 valence electron. Now, if we were to show reactivity, you have 2 options here. in order to get 8 valence electrons, you can either take out the one on the outside or you could add in 7. You have to do which one is easiest. So if I go back, I would take out that 1. Removing 1 electron is very, very simple, which is why this element is very reactive. It's easy to lose 1 electron. The second group of elements is called the alkaline earth metals. And the alkaline earth metals are in group 2, so we're moving to the right. They're all metals. They have valence electrons. They are reactive, but they are less reactive than alkaline metals. And alkaline earth metals tend to be silver in color, and they have higher densities than alkaline metals, so they feel a little bit heavier. And then we're going to draw the element right to the right of sodium. So we're going to draw magnesium. Magnesium has 12 protons and 12 neutrons. And we'll draw our electrons here. We have 2 electrons in the first energy level, 8 in the next, and 2 valence electrons. And the reason it's a little bit less reactive than an alkali metal is that unlike alkali metals, you have to lose 2 valence electrons instead of just 1. Losing 2 is easier than gaining 6, but losing 2 is a little bit harder than losing just 1. So it's reactive, but just less reactive than your alkali metals. Our group 3 through 12 is a large part of the periodic table. Those are called the transition metals. They're all metals, and they all have 1 to 2 valence electrons. They're also less reactive than alkaline earth metals. So you might have noticed as we're moving to the middle, reactivity is decreasing. Because they're all metals, they're all shiny, they have good, and they're also good conductors of electricity and heat. There's 2 lines on the bottom of the periodic table. Those are called lanthanides and actinides. The lanthanides and actinides are just the parts of the periodic table that we can't quite fit. And the reason we put them on the bottom is just so that we can try and fit the entire periodic table on a page. It's trying to save space. Kind of like if you look at the map of the world, you know the world is actually round, but you have to rearrange some of the pictures, like we can't have Alaska way up next to Canada. They take it out and they put it next to the other states just so you can save paper. We know that Alaska is actually next to Canada, just so you know the lanthanides and actinides should actually be included in the transition metals. Group 13 is a really easy one to remember because you can look it up on your periodic table. It's called the boron group. And the reason it's called the boron group is because the top element, the one I highlighted in green, is also boron. So you can look that up in your periodic table on your test. The boron group is made of 1 metalloid, and that's boron at the top, and it has 5 metals listed down below. The boron group, if you look at the top of that group, it has 3A, 3 for 3 valence electrons. It is reactive, and they're all solids at room temperature. So we're going to draw boron, and boron has 5 protons, 5 neutrons, 5 electrons. So we're going to draw 2 electrons in the first energy level, and then 3 in the next. Group 14 is called the carbon group. And just like with the boron group, the reason it's called the carbon group is because carbon is the element at the top of that group. So carbon is the only nonmetal. And then we have 2 metalloids below and 3 nonmetals. Or sorry, 3 metals. There's 4 valence electrons, and you can see that on the top of your periodic table where it says 4A. Reactivity varies among elements because metals still tend to lose valence electrons, nonmetals still tend to gain. But one similarity they all have is that they're all solids at room temperature. So we're going to go ahead and draw carbon. Carbon should have 6 protons and 6 neutrons. Should have 2 electrons in the first energy level and then 4 in the outside. Okay, group 15 is the nitrogen group. And the nitrogen group has 2 nonmetals, 2 metalloids, and 2 metals. It has 5 valence electrons. The reactivity varies among the elements. Anytime you have metals, metalloids, and nonmetals, you're going to see that. They're all solids at room temperature except for nitrogen. So we're going to go ahead and draw nitrogen. Nitrogen has 7 protons and 7 neutrons. It has 2 electrons in the first energy level and then 5 in the outside. Our next group, group 16, is called the oxygen group because the element at the top is oxygen. There are 3 nonmetals in this group, 2 metalloids and 1 metal. This group has 6 valence electrons, which you can see from the 6A at the top. Once again, it's reactive. They're all solids at room temperature except for oxygen. So we're going to draw oxygen over here. Oxygen has 8 protons and 8 neutrons, 2 electrons in the first energy level, and then you're going to draw 6 in the outside. Group 17 has a distinct name. It's called the halogens. The reason it's called the halogens is because every single element in that group is a nonmetal. Kind of like how when you have all metals, you got a specific name too. They have 7 valence electrons. Since they have 7, they are very, very close to having full energy level. And since they're very close, it's very easy to get 8. It means they're very reactive. They tend to be explosive. And since they're all nonmetals, they're bad conductors of electricity and heat. So we're going to draw in, we could draw in fluorine or chlorine. We'll draw fluorine. That's that first element on the top. And fluorine has 9 protons and 9 neutrons. It has 2 electrons in the first level, 7 in the outside. You're 1 away from getting to 8. So the reason it's very reactive is it is very simple to just add 1 more electron into that cell. Our last group is called group 18. And group 18 is called the noble gas. They're all nonmetals. They all have 8 valence electrons, except for the one exception is helium. Helium only has a total of 2 electrons, which is why it only has 2 valence electrons. The noble gases are unreactive. And the reason they're unreactive, if we draw, you can draw neon over here. Neon has 10 protons and 10 neutrons. We should put 2 electrons in the first energy level and then 8 in the next energy level. The reason it's unreactive is because if you already have 8 in that outside energy level, it does not want to change the number of electrons, so it won't form bonds and it won't react with other elements. Our last element we didn't have inside the group is the element called hydrogen. And the reason hydrogen is on that left side of the periodic table isn't because it's a nonmetal, because it only has 1 valence electron, just like the rest of the alkali metals. And hydrogen is also reactive. because if you don't have a full energy level, you need to change the number of electrons. So we'll draw hydrogen. Hydrogen has one proton and one neutron, and only has one electron. So it's very, very simple for a hydrogen to add in one more electron if it can find it. And that covers everything for our periodic table unit.